Good afternoon, everybody. My name is Andrea Bianchini, and yes, I am a dude, surprise. Many times when I come to countries like the US where Andrea is a female name, I feel a little embarrassed because people that see me with my beard, they look at me very strangely and say, oh my God, I thought you were a girl. This time, actually, I'm happy about this misunderstanding because I think that this is the only real reason why the organizer decided to netcast my presentation for some sort of diversity reason. They thought I was a girl. So they say, okay, let's netcast this. I don't see any other reason, but I will I will interest you nevertheless. So today I'm going to talk to you about a project we are carrying on in Europe about federated authorization. Before I start and I continue, I would also like to thank Martin, who is here with me, and Lala and Marco, who is not here with me. In fact, they are amongst parentheses, but heavily helped during this process and these activities. So in the activities, in the presentation that we are going to have, I'm going to guide you through a very short introduction about some basic concepts that we consider to be relevant to this field of study, this field of application. Then I will guide you through the experimentations that we are having to use Grouper as a central system to manage this kind of federated authorization, as we like to call it. Then I will guide you into 3 use cases that should prove, and I hope they will, that our choices, the choices that we made are sustainable and robust. In the end, I will try to show you some advantages that we see in the approach that we propose, and then, of course, some conclusions. So let's start. So the starting point that we had is that currently in Europe, like in many places of the world, we do have a very well-established identity federations. These identity federations were able to build a very good mechanism to build a common trust and to solve one very big problem, which is authenticating users in a very distributed and, let's say, not centrally managed environment. So via identity federation, we are now able to manage user identifications by, let's say, creating the IDP communication mechanism that we all know about, which delegates the responsibility to manage users to the right persons into the ecosystem. The main task of identity federation is to authenticate users and then to provide a set of attributes, a set of information about these users after they logged in. Since this approach proved to be really effective into this authentication mechanism, we tried to find a way to extend this mechanism to support better also user authorization. So this is the references of the project that is started something like less than 1 year ago in Europe to try and tackle this problem. Is a GN3+ project, which means a project inside GN activities, and it's a research activity. So before we continue, I would like to guide you through a very 2 simple definitions. You may not be completely, you may not completely agree with them, but this is the standing points where we started. So we can say that authentication is the act of proving that a user is actually who is claiming to be. So we have a mechanism in place to confirm the identity of a user. But this is not enough into, let's say, the IT world, because we can say that one person is exactly who he claims to be, but we also need to understand what this person is entitled to do, which resources he is entitled to use and consume. These other aspects are managed by another process which is called authorization. And authorization, as you can see here, is a function that has the task of specifying access rights on resources, IT resources, for example, but not only them. So more formally, we can say that authorize means to define and maybe also enforce, of course, an access policy on resources. So my standpoint was that identity federation so far was very good at solving the problem of authentication, but they are still trying to find a good way to solve the problem of authorization. This does not mean that nothing has been done into these years to solve this problem, because this is a real problem without which, real applications in IT systems cannot be used effectively and in a correct way. In fact, traditionally, the authorization process has been solved into 2 different, let's say, opposite approaches. The first approach that we can mention is the so-called SP Managed Authorization. This is the way we call this. What does it mean? It means that, well, the federation will only authenticate user, and then it's up to the SP, so to the application itself, to decide what to do with the list of users coming in and decide which resources they can access and which not. This is for sure the simplest approach and solution to be put in place because basically we're not giving any solution to the problem. We're only putting the problem into the SP space. And the SP, to solve this problem this way, needs somehow to take some sort of list of the users which are, let's say, able to access the system and the resources they're able to manage. So this solution is not bad in general terms. I presented it more, let's say, as a bad idea, but it's not actually. It's a good solution. It can be used in many use cases. It supports many use cases, but in our opinion, creates a little problem. And the problem this solution creates is that the SP, to do an effective authorization, needs to have some sort of information about the users accessing the application. So this is somehow a violation of the global design of the identity federation as we build them. And so this is something that we do because we don't have better solutions so far. The other approach, which is the opposite one, is the so-called IDP Managed Authorization. In this case, what happens is that, I mean, it's not the IDP who is enforcing the authorization, of course. The enforcing of the policies still remains into the SP, but this enforcement will be done applying rules upon attributes which are released by the IDP. In this sense, it's the IDP which is, let's say, governing the authorization, because when the user logs in, the IDP will provide the attributes that will be used for the user to access to certain resources on the SP. This second approach, once again, is good and can solve a lot of problems in many use cases. We use them very often in Europe, but I think also here there are many use cases, many applications using this kind of authorization process. But in our opinion, it leaves behind one point which is very important, because this time the SP does not have to know anything about the users, so we may say, okay, we are good. But the problem is that this time the IDP needs to know something more about the application he is serving. The IDP needs to know which attributes, which entitlements, for example, it needs to release for a particular user to grant the correct access. So these two approaches are good and are in place. They can be implemented very easily in existing federations, but our opinion was to try and, let's say, move out from these two schemas and provide a new schema which has different concepts behind. Our idea was to create a central authorization system that can be based on different technologies, and into this system we can provide an authorization process that is able to be delegated to the right subject or the right, let's say, administrator who now has the full information to manage authorization for the users. So we are not delegating to the SP, where probably there is not enough information. We are not even delegating to the IDP by itself, but we are implementing this system which is able to delegate accordingly to the needs of the application to the right administrator, the task of managing authorization. So, of course, to implement this tool, we wanted to try and test this solution, and we decided to use Grouper. Grouper, I think you all know it very good, maybe probably better than I do. But the way we try to use Grouper is to use it as, let's say, an inter-organizational tool. So we have one instance of Grouper in which people from different organizations will have access and manage different groups or families of groups, or stamps, I mean, in Grouper terms. So Grouper, in our configuration, will be the tool that will be able to manage in a central place all the groups for users, and also eventual authorization attributes that can be used to authorize user and consumed by the SP. So this is Grouper. Unfortunately, this is an old slide. There is a brand new UI interface, which is better than this. But as you can see from here, in our testing, we created an instance of Grouper, and we started to create stamps. And below these stamps, we created groups. And our idea is that we can, let's say, delegate the management of some of these stamps to particular users belonging to different organizations. The stamps, just to to clarify is the folder-like icons we see on this screen. So now, having this grouper solution, we wanted to prove if it is able to, let's say, concentrate and manage all the authorization activities for different applications. And so what we did is that we started to build a proof of concept to verify if grouper is really able to operate as described, and to also to try and understand which are the main problems or the main tasks and activities that we have to do to achieve this design. To do that, we started to create this proof of concept by identifying some key applications, which are, the applications that better describe the family of applications that our communities use. So we decided to create an integration for authorization purposes of a Mediawiki application to be representative of all the wikis. Of course, there are technical details that we need to take into consideration, so the solution for Mediawiki will not work for Confluence or other wikis, but basically the concepts behind one wiki will be similar to the concepts behind other wikis because they're providing the same service. Then we decided to integrate another application, which is a Moodle application, once again to be representative of a learning management system. And then we decided to try and implement a custom application being, here there is not the name, but being Garviks, which is an application we are developing in Gar, which is the Italian Ain where I work. And this Garviks, as the name suggests, is a sort of Dropbox, but completely private, completely built by the educational and research, by us from Gar for the education and research community. So the idea behind taking these two SPs was that, they are representative of a lot of real applications. They are somehow representative of basically quite anything we do in education, but also in research, they find some interesting point. For sure, we are leaving behind a lot of possible other applications, but we needed to start from somewhere. These three use cases, as we will see during this presentation, also offered, let's say, a growingly complex scenario use case, because Mediawiki was the simplest application to integrate with Grouper into this schema, while for Moodle application we needed to add some new functionality, and for the custom application we will need to add some other more. So these three use cases also proved, use cases which are more and more complicated, which is good in our opinion, because we are developing knowledge and also trying to tackle new problems and new situations. So starting from the first use case, Mediawiki. So Mediawiki is a wiki, you probably know it, and when we want to externalize user authorization to a wiki, what we want to do is that at a very basic level, we want that when a user logs into the wiki, apart from his username, for example, the user is also provided with some group information. This group information will be used to describe which parts of the wiki the user has access to, and in which way, let's say, if the user can only read some section or read and write another section, and so on. To do that, we implemented an integration of Mediawiki, which happens basically at login time. So when user logs in into the wiki, the usual SP IDP communication will happen. And after this communication, the SP is instructed to communicate with Grouper to retrieve group information for the user. This last communication is done leveraging the attribute authority, which is a SAML specification. The reason why we are so much concentrated on SAML is that our federation in Europe are based basically on SAML and on shibboleth implementation, not only, but in Italy at least mostly a shibboleth implementation. And so we wanted to, let's say, integrate Grouper in a transparent and, let's say, seamless way into the SAML federation. So to do that, we implemented this attribute authority interface, which name is very curious because AA, it's very funny to think about that. What happens here is that the SP is able to retrieve group information from this central system in a transparent and very easy way. The changes in configuration at the SP level consist basically in 3 lines of configuration into the configuration file. So this is very easy and very straightforward. I would like to stress another point here before we move on, which is a general point. When we integrated Mediawiki and also the other application we integrated, we wanted to concentrate on a problem which is wider than the simple problem of the user has or does not have access to a specific application. So we are not only providing a binary information, yes or no. We want that a user that accessed an application as a yes, as an answer to the question before, but we also wanted to describe the role the user has into the application. So it's not only access, non-access, but it's access with which kind of role. So this is, the way we implemented it into Mediawiki, and it's very simple and straightforward. Talking about Moodle, the situation becomes a little more complex because, well, for sure, Moodle needs the same integration at login time that we have in Wiki, in the Mediawiki. Why? Because when a user logs in, we need to check, what he can do and what cannot do, and eventually update his access control-based rules to the application itself. But there is also some other requirements that Moodle has to integrate with Grouper. In fact, when we talk about the authorization of Moodle, we are talking about, since Moodle is a learning management system, we are talking about courses, and we are talking about being student or teacher of a specific course. So we decided to integrate Moodle with Grouper by defining groups in Grouper, which represents courses. And then we have users, subjects, participating to these groups with different roles. So for example, we can say that if a user is a member of a group, a normal member, he is a student for that course. And if the user is an administrator for a specific group or another kind of role, he is the teacher of that course. So this is good. We can retrieve this information at login time. But as I said, we also have another requirement from Moodle. In fact, Moodle, if you know it, it shows you a list of all the available courses on the platform. To do that, somehow Moodle must be able to retrieve from Grouper a list of all the groups that are present inside the Grouper that represent courses, so under, for example, a specific STEM. This interaction will happen offline, so it's not bound to any specific login from a specific user. And we'll need to obtain two sets of information, a list of the groups, so a list of the courses, and the list of teachers and students of every course. So a list of, let's say, members of every group inside Grouper. To implement this offline integration, let's say, we decided to use a standard protocol which is called VOOT. Martin talked to it a few minutes ago in another room. So VOOT is a protocol which is specifically designed to solve the problem of group representation amongst different applications. So if you can see in this slide, VOOT was born to exchange group information amongst different applications and has a very simple and straightforward REST API in which you can query a server to obtain information about the groups, about the people who participate to a group, and other functionalities we didn't use. So basically we wanted to use this protocol because it's gaining momentum, so it kind of becoming some sort of shared protocol. And we thought that by implementing this protocol instead of integrating directly, for example, Grouper web services, which are available and works on a similar logic, we may be able to switch or change the technology behind the central group management system in the future if we may have the need to change it. This is a promise. Every time you do an integration, you try to use common protocols because it should be transparent to change. It never is, but we tried at least to minimize the amount of effort that we need to put into the change of the technology if we will decide to change it. So given this VOOT protocol, to implement this VOOT communication, we installed the VOOT connector on Grouper, which is available to the community in the Grouper, let's say, code space. And then we use it to communicate with Moodle. So the general integration is represented by this picture. So as you can see, Moodle will communicate with Grouper offline by a specific plugin, which is typical of the Moodle, let's say, way of working, which is called the enrollment plugin. The enrollment plugin is a family of plugins that takes the responsibility to get courses and participants to courses from an external source. Moodle do provide already a lot of enrollment plugins. One of them is an external database enrollment plugin that is able to connect to an external database, but we didn't want to do that because, otherwise we're very strongly dependent on the way the database of Grouper is modeled. And so we implemented a new plugin, which we call the Vote enrollment plugin, which is responsible to retrieve group information and user information, say user participation to groups, from Grouper via the Voot interface. So with this plugin, Grouper basically with a cron job, so basically any few minutes, depending on your configuration, will contact Grouper, obtain a complete list of courses, and update its internal representation of the courses, depending on what's obtained from the Voot connector. So this offline integration will happen continuously and will keep updated the database of Moodle. But as we said before, we also have this, let's say, online integration at login time, which is depicted by the cloud below this picture. So when a user logs into Moodle, he logs in via the usual SAML federation, and the enrollment plugin, once again, is responsible to go and check that nothing changed into Grouper about his authorization description and authorization policies. If something is changed into Grouper, the Moodle application, and so the enrollment plugin will perform the, let's say, adequate operation on the database to reflect the real authorization level of the user. And this control adds some sort of more security to the offline batch synchronization of groups and courses. Because something may go wrong and we may have users having access different than they should. So basically, as you can see, this second use case was not very difficult to implement, but added another functionality, which is obtaining listing of groups and listing of users participating to groups. This kind of thing was not a requirement for the wiki application. Okay, and at last, the third application, it's a custom application, the so-called Garviks application. We wanted to implement this kind of use case, and this is the only slide I will show you, and the reason for that is that this is the only part that we have not yet implemented into the POC, so we are still designing and implementing this integration. But we wanted to study a custom application, how a custom application could be integrated into this central authorization system. Because we wanted to understand, if we can achieve better results starting from a greenfield, instead of taking an existing application with its existing logics and trying to put the things together. So we tried to think, what happens if I could do whatever I want? I have a brand new application which is coming to life. I can do whatever I want. I can implement all the logics I want. So, this would simplify, or, we'll leave the problems as they are in the real applications, in this process. And then we also think that this use case is particularly interesting because it has the same, let's say, general problems of the Moodle example we have seen before, because we need to verify user authorization attributes at login time, for sure. We also need to have a sort of listing of the available groups and participation to groups, because in a Dropbox-like application, we would like, for example, to create a common area of data that we want to share with a group of work of people that works together with us. And in this case, we need to understand which are the available groups I can share data with, and which are the people belonging to these groups. But this application also creates another small problem, which is that we also need some additional authorization information, which are basically bound to some additional attribute that needs to be used for authorization. Just to explain you this, you have to consider that, for example, into Dropbox, you have a quota. So you have 20 gigabytes, 5 gigabytes, 2 gigabytes of space that you can use on that server. And this information is an information that is completely managed by the application, of course, but it can also be seen as a sort of, let's say, authoritative information. So the total amount of space that you have available depends on how much you are authorized to use resources. So we will try to externalize also this additional attribute and put it into groupers somehow, so that it can be collected at login time by the user to be enforced, but also maybe at a batch time for, let's say, a sort of a scheduled job to verify if some user is going out of space on the guard Dropbox he has available. So as you can see, these three use cases, as I told before, has a growing complexity, and the reason why we wanted to try and implement all the three of them is just to test all these kind of growing requirements and complexity. So why are we doing all this? Which are the advantages we see in doing that? So if you remember the agenda, I will try to provide some sort of advantages, a description of what we see as the advantages from different points of view. So I will try to understand which the advantages are for an SP point, from an SP point of view, which the advantages are from an IDP point of view, and which the advantages are from a federation operator point of view. And the reason for that is that I think that when you provide something new, some new solution, you also have to think, I mean, you try to wear somebody else's shoes before you, you propose that as a good solution. So talking about GSP, we think that this solution is able to provide a benefit because it is basically, in the most, let's say, elementary explanation of the solution, it's splitting authorization task into two activities. The first one being policy description or attributes representation, and the second one being policy enforcement, or let's say the decision whether to grant or deny access to a specific resource. It seemed somehow reasonable that the SP could continue to manage the policy enforcement part of this, let's say, dichotomy. But what we tried to do is that we tried to bring the attribute representation, so the policy description part, out of the SP, because we thought that this is not responsibility to the application developer deciding which person and which roles, let's say human understandable roles, do need to have access to specific resources. What he only needs to do is that he needs to, let's say, specify a mechanism to apply this kind of policies. So in this way, we are bringing this policy description out of the SP and bringing them into Grouper. And one other point I will stress very often into the last slide of this presentation is that this, representing this kind of thing inside Grouper permitted to have a delegation mechanism in place. So we could have the right person who has the right knowledge to take care of this point and to manage this information inside Grouper. So regarding IDPs, well, IDPs will stop doing anything related to authorization into this scenario because they will only authenticate user and provide the basic information about, I mean, let's say the demographic information of the user, name, surname, email, eventually, things like that. All the other informations, so the information related to authorization, are managed by Grouper, and inside Grouper, once again, we do wanted to implement a very strong delegation mechanism. So this approach proved to be effective because the IDP does not have responsibility, does not pertain to him. At the same time, the overall process of maintaining this kind of information and data is completely clear, completely under control, and very well, let's say, documented and monitorable. So we have a very clear accountability. Given that Grouper is managing this information, Grouper is also able to provide a very detailed audit log that will show what's happening, why it's happening, why some person had some specific grant or not. So at last, from a federation point of view, federation operator point of view, we think that, I mean, the key aspect is once again the delegation, because what we are doing here is that we are leveraging the circle of trust that we built into Identity Federation to, let's say, manage also other aspects about authorization. So with doing this, we are trying to, let's say, enforcing the circle of trust that we already have built. The reciprocal trust among the different parties is already present. And at the same time, the authorization attributes provided by Grouper can, let's say, transparently integrate into Identity Federations as we know them. We have seen via the AA interfaces or via the VOOT protocol, which should be very soon a good standard. So from a federation operator point of view, this seems to be a good solution because it permits to have control, it permits to leverage the circle of trust that we are building, and at the same time, I mean, everything continues to work in a coherent and, let's say, without any particular modification way. So this slide shows you, just if you're interested, to the basically milestones that we have in our activity project. As you can see from the dates, we are, we have finished the design phase. Well, actually, the design and the build phase are somehow overlapping. We designed and built each of the 3 use cases somehow in parallel. So we designed and implemented the first 2, and the third one about the custom application is still under design phase, let's say. But by the end of the year, we plan to finish this part. And so we plan to have the complete POC available. And in 2015, we will start what we call the dissemination program. So we will start to try and, let's say, go out to the communities and to other experts like you, for example, to describe this solution and also, raise comments or observations and see, if it can solve real problems. So to conclude, this is my last slide. We think that this approach has proved to be really effective in managing authorization in a more, let's say, federated way, as I promised by the title. And we think that by continuing the POC, we will be able to identify the key problems and the key aspects that we need to take into consideration for such a kind of solution. The next step could be to start and use this solution and this architecture into real production environments. Luckily enough, next year in Europe, we will start a new project, which is the new version, let's say, of this GN3 Plus project. Will be Gen 4. And into this project, we will plan to use this kind of solution to manage all the authorization aspects of user participating to the project. So we will have wikis and other applications that are supporting real research projects. And we will use this schema to provide authorization information. And so we will see if it works or which are the problems into real production environments. So thank you very much. Basically, that's it. If you have any question, comment, maybe something we did wrong, we are very happy to hear. Yes, please.
Hi, I'm Keith Bussell from the University of Illinois. One of the advantages in my mind of leaving the authorization in the hand of the SP is even if the user isn't authorized, they have the SP has the data to give the user a detailed explanation of why they don't have access. I definitely agree with your scenario of not giving the SP user data that they don't need. My question is, with this scenario, what can the SP do to give the user some intelligent type of error? Yeah, because they're not getting any attributes about the user, correct?
No, in my opinion, I think that a way to solve this problem is that, it's not true that the SP does not know anything about what's happening about authorization. The SP will know that the user will not be able to perform, let's say, a specific operation because he is not part of a specific role. So it does not have enough, let's say, clearance level or grant level. So the error message could be also provided to the user by describing the reason why he is not able to do that. Because, for example, he is not part of a specific group which has specific, let's say, grants to do specific operations. But what I think is crucial is that to provide good messages to the user from the SP side, I think, but I may be wrong, but I think that it's of no use knowing the name, the surname, and the username of the user accessing the applications, because probably we are managing authorization not on a by name policy, user by user, but by grouping the user together. So having the group information should be enough to provide good error messages. This is at least what I hope. I don't know if I answered.
I wasn't quite clear on the the exact flow of information between the IDP, the SP, and the attribute authority. So how would and who decides which attribute authority in a federated context gets used for that particular authentication / authorization event?
Yes, this is a very good question because this is a problem that we need to face. This approach is straightforward as far as we have one attribute authority, so one group or management system. But if you happen to have many of them, who decide which one should be contacted for this purpose? So to this question, honestly, at the moment I don't have an answer. I don't know, Martin, but I think we don't have an answer because the scenario we're trying to implement is to have one central system that manages this kind of aspects, at least for one project or for one, let's say, small community. Or also bigger, but I mean, we would like to start small since we are experimenting. So it would be easy to understand who is going to release these attributes because it would be the only one system available. But if we have to scale this in a more, let's say, complex scenario, this is a real problem.
Yeah, if I may elaborate on that. Yes, it's true. The case we're now searching at, for instance, is being one group, for instance, to a couple of service providers. So it's that one use case. However, if you go to the scenario that you have really a truly federated service provider, that is also the case we're searching with food, that you could have several group providers. Yeah, then it's possible that you can get several attribute authorities, and if you get several attributes which are incidentally the same or conflicting, yes, that's something we have to dive into, but I'm afraid we could never solve it completely. At least then it's a decision of the SP to what amount it trusts each attribute authority, as well as to give it a specific order.
Even if you're not at the point to where you can tackle that conversation yet, at a conceptual level, is it up to the once you decouple the IDP from the attribute authority, there comes a question as to whether it's the SP's responsibility to choose the attribute authority, or is it the user's responsibility to say that I want my attribute supplied by this particular authority, just like it's the user's choice to pick the IDP.
Yeah, exactly. In authentication, the discovery is guided by the user. So the user can choose which IDP he has a valid credential on. In this case, I don't think this is a good solution because the user is not, cannot choose, which attribute authority is able to provide the right access for him. It's a too technical detail for him. But it's something that we need to discuss and also design how we can do discovery of these attribute authorities.
Yeah. Definitely, and it's also a little bit
over time,
depending on the
one last question, which is probably the most difficult one.
On the scenario, I'd like to say. Thank you.
Because Bob is very.
This is really wonderful looking. Outside of the design that you've been testing, somehow the users who may have their credentials in different IDPs have to end up listed in group memberships and things like that. How do you expect to do that as you move towards production? I'm wondering if you've thought about that. What will be the workflow like to put the users into the appropriate authorizing groups before they get to the application?
I think that here we have a very big problem that is about, let's say, provisioning users inside Grouper. To do that, we came here also to try and find some solution because the problem here is that we need to have users which are belonging to different IDPs, so also to different organizations in our case, to be provisioned inside Grouper at least with some minimal information that is enough to have elements to do authorization on them. So this is one side of the problem, and the other side is that once we have the users provisioned inside Grouper, we need to assign them to real groups. Unfortunately for that, I do not see any specific opportunities than designing, let's say, workflows by leveraging the use of the technologies we may have co-managed or whatever that has some sort of manual intervention because we also have to verify what we are doing. It cannot be completely automatic. But this is one aspect that is crucial in real production environments, so we will test for sure with this project, and can also add that another aspect that I see crucial is the auditing process, because I mean, since we are doing research, it's all very simple and easy, but when we're trying to deal with tiered users and authorizations, we have to take into consideration these aspects. So I think that by proving in real production environments this solution, we will be able to, let's say, have best practices on how to solve these problems which are at our attention. Do you have anything to?
No, I agree. You have to do some kind of workflow to get it in Grouper, and yeah, that is a challenge.
Thank you.
Thank you very much.